Cramer's rule. So Cramer's rule says if we take a system, and I'm going to make a generic system here, ax plus by is equal to e, and cx plus dy is equal to f. So I'm again using my a, b, c, d, e all the way, or just as variables to represent constant values, and then x and y are our variables for our equation. So Cramer's rule says we can follow a couple of steps. First thing we want to do, step 1, is make sure they're in standard form. Which we're good to go. We've got our x comes before our y here in both of these, so we're standard form. We're done with that step. Next thing we're going to want to do is find the determinant of our coefficient matrix. So I'm going to say A is equal to a 2 by 2 matrix, and we're going to plug in the coefficients of our variables. And this is important why we want it to be in standard form. We want the x's to be in our first column and the y's to be in our second column. So we'll just plug in those coefficients in the same exact order. And we want to, this is making our coefficient matrix. That's called our coefficient matrix. So step 2, get the coefficient matrix. Step 3 is to find the determinant of the coefficient matrix. So find the determinant of A. And then once we get the determinant of A, we can use that in our next steps to find x and y. So step 4, we can say x is equal to the determinant of a new matrix over top of the determinant of A. So this new matrix that we're going to find the determinant of is, we're simply going to take our solutions of E and F, and instead of plugging back in, or instead of using our regular coefficient matrix, we're going to swap out our x column, our A and our C, with the solutions E and F. So in our first column here, we'll plug in E and F, and then we'll take the same two coefficients for our y column and keep those and plug those right back in. So we'll get the determinant of this new matrix here over top of our determinant of A. And then for y, our last step, we're going to do something very similar, where we'll have the determinant of a new matrix where we're taking, this time our x column stays the same, so we have A and C, and we're substituting in E and F for our y column here. And we're plugging that all over the determinant of A again. All right, let's take a look at an example problem using Cramer's rule now. So if we have a new system here, 2x plus y is equal to 8, then x minus 2y is equal to -1. So first step, let's get our coefficient matrix. We have A is equal to 2, 1, 1, -2. Find the determinant, or first step was make sure they're in standard form, but I already wrote them in standard form. So I'm starting here with our coefficient matrix. Next up, what we want to do is find our determinant. So the determinant of A, we're going to take 2 times -2, which is -4, and subtract away 1 times 1, so -1, which will get us a determinant of -5. Now we can take our variables x and y and solve for them. So let's make our new determinant matrix here, where we're just going to swap in, instead of our 2 and 1 here for our x column, we'll take 8 and -1, and then plug back in our y coefficients of 1 and -2. And we're going to put this all over our determinant of -5. So now, finding the determinant of our top matrix here, our new determinant, we've got 8 times -2 minus 1 times -1 all over -5, which will simplify down into 3. So x is equal to 3 in this case. Now let's check out what we get for y. So y, the new determinant that we're trying to find, we're again going to swap out our solutions for our y column here. So our x column remains unchanged. And now we'll get 8, -1 in the back on our second column. We're going to put that again all over our determinant of a, our -5. So this time around, we'll get 2 times -1 minus 8 times 1 all over -5, which simplifies down to 2. So our solution for this system, we get the points 3, 2, x is 3, y is 2, and there we go. We have our final solution right there. So let's give you an opportunity to practice this again, where I'll give you another example matrix or system. So try out 3x minus y is equal to 5, and 2x plus 4y is equal to -6. Go ahead and pause the video and see if you can use Cramer's rule to find the solutions for x and y. All right, so starting off, should have noticed they're in standard form, so we're good to go here. Now let's find our coefficient matrix. A, we should get 3, -1, 2, and 4, where we should find the determinant of A is equal to 14. Then when we're solving for x, we'll get the determinant of 5, 6, -1, 4, all over our determinant of 14, which will get us 14 over 14, which is equal to 1. So x is equal to 1. Now let's try for y. This time around, we should be getting -28 over 14, which is equal to -2. So our final solution here is 1, 2. So Cramer's rule makes it really nice and easy to find these solutions. And it's especially nice to use with a 3x3 matrix. So let's take a look and see how we can apply this to a 3x3. So I've got my 3 equations that I'm making. I'm again putting them in standard form just initially to make them a little bit easier. Now we want to take our coefficient matrix, the same thing we were doing. We're going to take, this time we're going to get a 3x3 because we have an additional equation and an additional variable here. So now we'll have 2, 1, 1 for our x's, 1, -1, 3 for our y's, and 2, -1, 2 for our z terms here. And we know we're going to need to find our determinant here, so I'm just going to go ahead and copy down my first 2 columns again. And if I want to find my determinant, I'm going to need to find my 6 products here. So the determinant of A, which when we do so, we should be getting -4, -1, plus 6. And we'll subtract away our -2 minus our 6 plus 2, which is equal to 7. And again, those numbers just came from finding our 6 diagonals here. Now once we have our determinant, we can find our 3 variables this time, following the same process as we were before. So now we're going to say x is equal to a new determinant where we're taking, again, our x column and replacing it with our 3 solutions here, our 3 final answers. And then our y and z columns of our coefficient matrix will remain the same. So we get 1, -1, 3, 2, -1, 2. So now we have another determinant, and that's going to be all over the determinant of our coefficient matrix of 7. So I won't show you, I feel like at this point you should be fairly comfortable with our determinant, so I'm just going to go ahead and say this is equal to x over 14 over 7, getting us x is equal to 2. Now let's try for our y. In this case, our x column of our coefficient matrix will remain the same, our 2, 1, 1, and now we're plugging in our final answers here for y, so we'll get 9, 0, and 5. And then our z column also remains the same. And that again goes all over our determinant of 7. Now when we calculate this next determinant, we should be getting -7 all over 7, which will give us y is equal to -1. And last up, we've got our z variable here. So again, our first two columns now will remain the same as our coefficient matrix. And we'll swap out our 905 for our z column. So z is going to equal 21 over 7, giving us z is equal to 3. So our final solution here is 2, -1, and 3. All right, that wraps it up for this lesson. I'll see you all in our next matrices video. Take care, everybody.